So when given a type of question, as we have in this case, we are given that if cos 52 degrees is equal to k, find each ratio in terms of k. Each is supposed to be in terms of what you are given here. These are typical questions of your numerical reduction as we had before. But now it is having algebraic ratios. So the concept is, which part here are we referring? Algebraic ratios. We are saying we are going to apply the numeric reduction. Yes, we are going to use it as we had previously our numerical reduction. We are going to use it. Whether they are positive angles or they are negative angles. But you are given something before that. A certain ratio which has an algebraic ratio like what we are given here. The cos of 52 degrees is equal to k. What does it mean? From our ratios, we do understand that from the concept of our SOHCAHTOA, we do understand that these ratios can be written as fractions. Sine of theta, cos of every ratio, the sine of theta being equal to what? Opposite over the hypotenuse. The cos of theta being equal to the what? Adjacent over hypotenuse. The tan of theta being equal to what? Opposite over hypotenuse, over the adjacent, I mean. So, as we have, or if we are given, let's say, sine 12 degrees is equal to P, it means something to us, this part, in terms of a ratio that a sine is supposed to have, opposite over hypotenuse, but we do not see it. We're just given P. Remember, 2 is same as 2 over 1 from our numbers. 3 over 1. So what about P? It is the same as sine of 12 degrees is equal to P over 1 like this. It is the same thing. So from there, we can properly see a ratio there. This is our algebraic ratio here. This is our algebraic part. You'll be given an algebraic term there, an algebraic expression, whatever that you'll be given. But in this case, we are having what? A term, a ratio there's as a term. So we are saying this algebraic ratio can be used to answer other questions, just like what you're given. Can be used to answer other questions. How can it answer other questions? We must know where this ratio was taken and what does it mean. The ratio of a sine, it's opposite over hypotenuse. So it means P represents the opposite. What about 1? The hypotenuse. So in this case, you can draw a triangle to represent the ratio. Draw a right angle, the right angle triangle. Right angled triangle to represent the ratio. So we need to represent the ratio, the given ratio. The given ratio. In our case, I'm just going to give this one as an example. So we're going to have a triangle like this, right? It's a right angle triangle. Just put, guys, a right angle triangle of your choice. And you indicate on this triangle to say, according to you, I'm just giving like an example, guys. Let's say it's 12 degrees. You indicate to say, this is 12 degrees. According to 12 degrees, remember, you name the sides of the triangle according to the angle. If this is theta, the angle, this one, opposite from our grade 10 mathematics, this is our opposite. 90 degrees and theta, they are adjacent to each other. And the longest side, the one facing 90 degrees, is our hypotenuse. It is because of where theta is. If you choose to represent your right angle triangle this way, and this is where you put your theta, it means it has changed. This becomes your opposite. Remember, theta is facing this side. So this will be your opposite side. Theta and 90 degrees, they are sitting adjacent to each other. These two sides, they are adjacent to each other. And this is our hypotenuse. The hypotenuse is the one which does not change, always facing what? 90 degrees, the longest side. So theta determines these sides. Theta determines these sides according to where you put it. According to where you put your theta. So in our case, if we decide to say this is where we are going to have our theta, which is our 12 degrees, it means according to this triangle, this is our opposite. This is our adjacent, and this is our hypotenuse. Knowing this can help you to fill in the given information to say, okay, you know that this is your opposite, and your opposite is what? It's a P. So you can represent this with P. Hypotenuse is what? It's 1. This side, it's 1. So what about this one that is missing the adjacent? How do you find it? You can apply your Pythagoras theorem. Remember your Pythagoras. From your grade 10 again, Pythagoras, our Pythagoras theorem. Hypotenuse squared will be equal to the square of these two sides. That is the case. So our hypotenuse squared will be equal to opposite squared plus adjacent squared. So hypotenuse is what? It's 1. So 1 squared is equal to opposite. What is our opposite? It's P. Plus adjacent. What is our adjacent? We do not know. It's the one that we need to calculate. So we can find it, but it will be in terms of P. Remember, we're talking about what? An algebraic ratio. So we must find it in terms of P. So guys, 1 squared, we know that one is 1. We take the P squared this side, it will be what? Minus P squared. Remember, we need to solve for A, our adjacent, this one. We need to find what is representing A. So 1 minus P squared is equal to what? Is equal to A squared. What about A squared? Introduce the square root to remove the square. The square root. This one is an expression. You can't determine the square root of an expression. Leave it like that. So it will be A is equal to the square root of 1 minus P squared, which is our adjacent this side. So it will be 1 minus P squared. That's how you can fill in your triangle, guys. From Pythagoras, you can fill in your triangle. And after filling in this triangle, you can answer for any ratio because it's now a complete triangle, this one, guys, where you know the sine of theta is what? Opposite over hypotenuse according to the ratio that we had. This is the one that we have. So we're not going to talk about this because it's already the one that we had. If we are talking about the cos of theta, it means the cos of 12 degrees is equal to what? Adjacent over hypotenuse. What is our adjacent according to this angle of 12 degrees? Our adjacent is this one. The square root of 1 minus P squared over the hypotenuse, which is 1. So remember, x over 1 is same as x. 2 over 1 is same as what? 2. So dividing by 1, it means it will remain as the square root of 1 minus P squared. We have determined it from what we had. Now look, we are now even finding the ratio of what? Of a cos in terms of P. We are given one ratio, but look, it is now giving us other ratios. We can even find the ratio of a tan. Tan 12 is equal to what? Tan from our SOHCAHTOA, opposite over adjacent. Opposite over adjacent. What is our opposite according to this? It's P. Over the adjacent. What is our adjacent? The square root of 1 minus P squared. Just like that. So if you know these ratios, guys, if you know tan 12, the cos of 12 degrees, the sine of 12 degrees, therefore you can even answer for what? For the reduction, right? Let me do this way. You can answer for reduction. Remember the reduction now where it plays a role. I want you to see where the reduction concept, because we are saying, guys, it's numerical reduction with algebraic what? Ratios. These are the algebraic ratios here that you had. So you now know, okay, 12 sine of 12 degrees is what? It's P, as you are given. The cos of 12 degrees is what? We saw cos of 12 degrees. It gave us the square root of 1 minus P squared, remember, of 1, and it remained like this. So questions now can be like this. They will ask you maybe to evaluate in terms of P, the value of cos. Let us just take, we're going to just take a simple example, guys. Cos 162, cos 168 degrees, like this. They will ask you to simplify something like this. This is a numerical value. Remember our previous class, when we were dealing with the numerical reduction, I was saying, you look into the quadrant. Where is it that I have what? Cos of 168 degrees. We have got cos of 168 degrees in which quadrant? 168 is more than 180 in what? In the second quadrant. Remember, we're talking about positive angles going this way. In the second quadrant, where in the second quadrant, the angles are written as what? 180 degrees minus theta. 180 degrees minus what? Minus theta. So you must use the reduction now to reduce this one to the what? To the acute angle. Remember, guys, your concept, 180 degrees minus theta is equal to 168. So that you can find what? You can find theta. Minus theta is equal to this one to the other side was going to be what? A negative there, minus 180. You subtract. It was going to give us minus 12 degrees. Then we divide by what? By minus 1 minus 1. Theta is what? 12 degrees. This one is 12 degrees. So it means cos 168 is simply equivalent to what? In the second quadrant, we know cos is what? Negative. So it's negative cos of the acute angle, which is negative cos 12 degrees. Theta is 12. So this is what you're going to have from the application of what? The reduction formula. You see now the reduction formula, it is playing a role. The reduction formula is telling you that this is supposed to be minus cos 12 degrees when it is being reduced. And you have that cos 12 because you have got what? The triangle. So that's the triangle now playing a role to say, okay, I know that my cos 12 is what? This one. So you substitute. So it's minus. What is your cos 12? The square root of what? 1 minus P squared. So you must know the reduction of this on its own, how to reduce this, guys. This was our previous class. So there's no way. You must know how to reduce. After the reduction, your answer now is in terms of what? The algebraic part that you're given. That's how you answer these questions. You can answer as many questions as you can, guys. So you want to quickly go through this activity and see what we are given, how to attempt these typical questions. But as you can see, it's just a straightforward path. So the hint, guys, you need to draw this part. It's going to be part of your what? Your simplification. Draw what and represent the ratio, this and that. So in our case, we are given the cos of 52 degrees. All right, cos 52. Let's take this one into consideration. The cos of 52 degrees is equal to K. So this one is a ratio, this one, K. So how do you write it as a ratio? Over 1. Find each ratio in terms of what? In terms of K. So remember cos. From here, cos is what? Adjacent over hypotenuse. So you're given adjacent and what? Hypotenuse. So you must draw the right angle triangle to represent what you are given before you even try to attempt this. Represent the triangle that has this information. So our triangle is going to be like this. It's an acute angled triangle, remember? So It's going to be in a right angle triangle. So, you know, guys, these ratios are used in a right angle triangle. So you choose where you want to put your 52 degrees. As for me, I'm going to use my 52 degrees here on the base here. This is where I'm going to have my 52 degrees. So according to this, I have what? Adjacent. A is the adjacent. Adjacent. This is our adjacent. Remember, according to 52 and 90, this is our adjacent. This is the opposite, and this is our hypotenuse. So the adjacent, we have it, is the one that we are given, which is K. Our hypotenuse is what? Is 1. This is your hypotenuse. So as you can see, this is the side that is missing your opposite. So how do you find that opposite? Using what? Your Pythagoras theorem, guys. That's where the Pythagoras playing a role. Hypotenuse squared is equal to what? Opposite squared plus what? Adjacent squared. Hypotenuse, you have 1 squared. What about opposite? You do not have. Adjacent, you have in terms of what? In terms of K. So that's K squared. 1 squared, that's 1. You take the K squared this side. So that's minus K squared is equal to what? Opposite squared. Square root both sides. So this is it. Our opposite is equal to the square root of what? 1 minus K squared. This we're going to represent our opposite. Wherever we see the opposite, it is now written as what? 1 minus K squared. This is the idea. You apply the Pythagoras. Grade 10 mathematics, remember? So with this information, guys, let us quickly now attempt our questions with this triangle and our reduction. So this is how you attempt. You find this cos 122. Cos 128, I mean, cos 128 degrees, 1.1. Cos 128. All right. So the cos of 128 degrees is equal to what? From our reduction, we're supposed to reduce these guys properly. 128. Where do we find 128 degrees? In the second quadrant, more than 90. Remember, 90 to 180. 180 degrees minus theta. It's a positive angle, this one. This is the quadrant for 180 degrees minus what? Theta. So what is your theta? What is the theta? 180 degrees minus theta is equal to what? 128. Find your theta, guys. Just even solve this one aside. Minus theta is equal to, you take this one to the other side. It was going to be minus 180 there. So 128 minus 180 was going to give us minus 52. Divide by negative. So theta is what? 52 degrees, which is our acute angle. It's what? 52 degrees. So if you know, guys, it was going to be cos of 180 minus this. What is the answer there? 180 minus theta cos is what there? Is negative. We are dealing with what? A negative cos. So just write your answer there. Negative cos of what? The acute angle. 52 degrees. So this is what you're supposed to have. We have reduced, we have applied our reduction, the numerical reduction. But we cannot end here because they said in terms of what? K. We do not have K on our answer. In terms of K. So what carries the K? Our triangle. According to this, what is the ratio of what? A cos. A cos is what? Adjacent over hypotenuse. So this is minus of the adjacent over the hypotenuse, which is minus. What is our adjacent? Our adjacent is K over the hypotenuse. Our hypotenuse is 1. So this is it, guys. Minus K over 1 is just same as what? Minus K. Just like that. So the reduction plays a role first. Then you apply the ratio according to the triangle. Reduction first. So that is where you're talking about numerical reduction with the algebraic subs. We have to substitute the algebraic part at the end. That is the idea. What about this one, cos 32 degrees? Because you might be wondering, what am I supposed to use there to reduce this one? All right. So for cos 38, for sine 38, this one on 1.2, you have got sine 38 degrees. You can answer it direct because you know that angles in a triangle, they add up to 180 degrees. So if this angle is 52, you subtract from 180, you're going to get 38. Remember, angles in a triangle, 180 minus 90 plus what? Plus 38. Or simply 90 minus 52. 90 minus what? 52 degrees. That's 38. The whole of this. Oh, sorry, this is 52 here, 52. This one is 52. So you're going to get 38 degrees. So it's a remaining angle of the triangle, this one, 38. This is where it is. So you can even use the concept, guys. This is a sign. It's already there on your triangle, 38. So you can even simply use a ratio opposite of what? Hypotenuse. What is our opposite according to 38? This becomes our opposite according to 38 degrees, guys. K is our opposite. Our hypotenuse is what? It's 1. So it's going to be K over 1, which is what? Which is K. You can use this concept to find the angle because it's an acute angle. 38, guys, is an acute. There's no need for reduction. Or you can do this way because you might find maybe difficult for you to locate to say, what about the 38? I'm now using properties of a triangle. You can even go back to say 38 degrees is an acute angle. So the only thing that I can use, because it's an acute angle, is the part of our core function. That's the only thing. Remember, from our core function, we said we can have acute angles, the sine of theta cos 90 degrees minus theta cos, this concept of your core function or your core ratios. It can also work. It can also work. So you're simply asking yourself this one, all right? So using core functions, we want to see how the core function was going to help us here. So from core function or core ratios, you are going to ask yourself to say, since you have 52 degrees and it is under what? A cos. Can I change a sine to a cos? Is it possible? Yes, it's possible because we saw that it is supposed to be cos 90 degrees minus what? Minus theta, theta, theta. Where this is theta, it will be 90 degrees minus theta. What is our theta? Our theta is 38 degrees. So it means sine 38, sine changes to cos. That is the core function. Sine to cos, but 90 minus what? Theta. So if we are to subtract this, 90 degrees minus 38 degrees, you are going to get 52 degrees, of which you have this one. Remember, cos 52 is the one that you are originally given. What is cos 52? It is K. You're done. You already have the answer. Sine 32 is equal to K. Sine 38, is equal to K. It is the same as what? Cos 52. Remember your core functions again. They play a role. They also play a role, as you can see. All right, so guys, I want you to use that, answer your questions. We're not gonna end, guys. There's so many questions. Do as many as you can. Let's just answer this one. So even for negative angles, you can do that part. For negative angles, you just have to figure out, guys. Remember, I talked about negative angles in our previous class. So reduce it to a negative angle first. What is the answer in that part? Reduce it first. After the reduction, then you put the substitution. Even when it is like this, 218, reduce this one first. 232, reduce every of this one, reduce them. All right, so let's focus on this one because these ones, guys, they are direct. We talked about these angles in our previous class. Negative 142, we also talked about this. Let's see, minus 142. Remember, negative angles, they go this way. So tan minus 142 will be equal to what? Where do we have that it is in this quadrant? So tan minus 142 degrees minus 142 degrees will be equal to what? In the third quadrant, as a negative angle, remember, is what? theta minus 180 degrees. So what is the theta? So we just equate, guys. Theta minus 180 is equal to what? Minus 142. So what is our theta? Our theta is equal to minus 180 to the other side. That's a positive. So you're going to add minus 142 plus theta. Minus 142 plus 180, plus 180. That's 38 degrees. So the angle there is what? 38 degrees. That's our theta. And in this quadrant, it is the quadrant of a tan. Tan is positive there. So it means it is going to be tan of what? Theta. Tan of theta. Our theta is what? 38 degrees. This is what we have, guys. If you are given this as tan theta minus 1, your answer was supposed to be what? Tan theta. But what is our theta? Tan 38. So this one, it remains positive. All right? That is the case. So this one was going to give us tan 38. And tan 38, remember what I talked about this 38, guys, to say from these angles, we saw this is 38 degrees, which is here. So the tan of 38, tan opposite over what? Opposite over adjacent. So our opposite, according to 38 degrees, this is our opposite, guys. Must be careful. So that's K over adjacent. According to 38 degrees, this becomes our adjacent. Square root of 1 minus K squared. Remember, I told you the sides are named according to the angle. So according to 38, this becomes your opposite. This becomes your adjacent. But according to 52 degrees, this one, 52, this one, this is your opposite adjacent. Do not forget. So that's it. Can we add more questions? Then we'll see from there where there are any questions, guys. Let's communicate so that we can have a recap or revisions. Question papers, because we're going to also do question papers. So more explanations can be found from question papers, of which I've done some question papers on trigonometry. So you can check there, apply this information. You see that it's one and the same throughout.